Okay guys, our last video started getting a little long, so we are going to do part 2 of the quiz questions. So we're going to do that back page, problems 4 and 5. So here we have a 10-gram marble sliding to the left with a velocity that has a magnitude of 0.4 meters per second. It's on a frictionless horizontal surface, icy New York sidewalk. Makes a head-on collision with a much larger marble that's sliding to the right. Okay, so we need a picture. You'll notice that I'm getting a little bit picky and saying, okay, now draw me a picture. So before the collision, I have a small marble that's sliding to the left. Let's see, I've got a small marble sliding to the left. So this is a 0.4 meters per second. And this is my 10-gram marble. Then I have a larger marble sliding to the right. So this is 0.2 meters per second. And this is my 30-gram marble. Again, nothing technical, but this is what's happening. Okay, so then we say, okay, the collision is elastic. What does that mean? If it's elastic, that means momentum is conserved. Momentum initial is equal to momentum final. That also means that kinetic initial is equal to kinetic final. That will help us here. So we want to find the velocity of each marble, magnitude and direction after the collision. So initially we have 0.03 kilograms times 0.2 minus, because it's going to the left, 0.01 kilograms times 0.4, and that's going to equal our mass times our velocity. So it's going to be marble 1. I'm going to call this marble 1, marble 2. So marble 1, velocity 1, plus marble 2, velocity 2. So this is going to be, if I look at my nice happy random number generator, 0.03 times 0.2 is going to give me 0.006. 0.01 times 0.4 is going to give me 0.004. So that's going to give me a difference of 0.002 for my momentum. That's going to equal mass 1, velocity 1, mass 2, velocity 2. Finally, I'm going to have on the kinetic energy 1/2 mv squared for each of them before, 1/2 mv squared for each of them after. So before, I'm going to have 0.03 times 0.2 squared times 0.5. So my initial kinetic energy of the big marble is 0.0006 joules. Then I have 0.01 times 0.4 squared times 0.5. So that's going to give me 0.0008 joules. So that's my initial kinetic energy. Mass 1, velocity 1 squared. 1/2 mass 2, velocity 2 squared. So over here I've got 0.0014 joules equal to this. So one thing I'm going to have to do is I'm going to have to solve over here for V1 or and then plug it in over here. So here if I say, okay, V1 is going to be 0.002 minus mass 2, velocity 2, divided by mass 1. And then I'm going to plug that in over here. I'm going to use that to solve. We'll go from there. Okay, so I'm going to FOIL this out, and I'm going to run through a few of these numbers here on what we need to get. So I've multiplied by 1/2 to get rid of this fraction on both of these terms, which I left on right here. Then I'm going to go ahead and I'm going to substitute the numbers for mass 1 and mass 2 and go ahead and FOIL this out. So we are going to end up with a quadratic. We will have to use the quadratic formula. We will. Okay, so let me simplify this and we'll come back. Okay, so I am quickly running out of space here. So I've got that this number is going to equal this 0.002 quantity squared divided by mass 1. Then I'm going to, as I FOIL this, going to have 0.002 times mass 2 divided by mass 1. They're a factor of 3 different. So that's where that 3 comes from. It's 30 grams divided by 10 grams. Then I have velocity of 2. Then I've got the 0.03 squared over the 0.01 times velocity 2 squared, plus this term just keeps coming down, the 0.03 velocity 2 squared. So I'm going to have the 0.0028, and I'm going to work through the rest of this. So let me pull out the calculator one more time. Okay, so we're going to end up with, when we combine these two terms, 0.12 velocity 2 squared. So you can see that we're really quickly getting into that quadratic equation form. So we're going to subtract this over. So we're going to get that 0 is equal to negative 0.00 24. We've got minus 0.006 V2 plus 0.12 V2 squared. Now for the quadratic formula, that's going to tell me that V2 is going to equal negative B, so that's 0.006 plus or minus the square root of that value squared minus 4 times AC all over 2 times A, so 0.12. So I'm going to plug these values in my calculator and we're going to see what comes out. Okay, so when we do the quadratic formula, we get two solutions. So we have this option and we have this option. So then what's going to be asked is, okay, well, what's going to happen? Which one do we choose? Well, if we go back here and we look at velocity 1, so keep in mind that our answers have to be consistent. We can't still have the larger marble going to the right if the smaller marble is still going to the left after it collides. They have to either be going in the same direction or opposite directions. They didn't just phase through each other. So if I put in the 0.169 meters per second, I get a negative velocity. Still showing this one's going to the left. So let me try putting in this negative. So that says this big marble's going to the left. So if I put that in my calculator, I've got 0.002 minus mass 2, 0.03 kilograms, times this negative mass, so negative velocity, 118. That's going to flip signs to a negative. And I divide that by my mass 1, that 0.01 kilogram. I get that this velocity has bounced back to the right. So in my mind, the better thing, what makes most physical sense, is for this to be the velocity of the larger marble and the smaller marble to have bounced off of the larger one back to the right 0.554 meters per second. Otherwise, it would be like they phased through each other, and that is not realistic. Okay, so we have a bullet with a mass of 500 grams fired into a block of wood that has a mass of 2 kilograms. That has been suspended to create a ballistic pendulum. That's what we talked about inside class. So we have a block of wood suspended. We have a bullet that comes in, strikes it, and then this whole thing swings up some distance and then comes back down. So our bullet becomes embedded right here, and it's going to swing up to some height h. A little exaggerated for effect, but you get the idea. So there's our picture. Our initial speed of the bullet. Well, let's work backwards. So we know energy is conserved. How do I know that? There's no external force happening on the system. So that tells me that potential plus kinetic at the bottom is going to equal potential plus kinetic at the top of that pendulum. At the top, the only thing is potential, so it's going to be mgh. At the bottom, the only thing is kinetic, so it's going to be 1/2 mv squared. Now this m, that is the mass of the bullet plus the mass of the block, because that is what we are looking at in the system. So we've got that the velocity at the bottom is going to be the square root of 2 times gravity times the height. Now you may notice that this particular piece keeps coming back. This is about the 5th time we've seen the square root of 2gh. It will continue to keep turning up, kind of like a bad penny. So velocity of the system just after impact is right here. So how am I going to go from just after impact to the initial speed of the bullet? So in reality, what I should do is I should just pick this all up and drag it right here, because it's going to keep coming back. So yes, the square root 2gh is just going to keep coming back. So we know the system is conserved after the impact. There's no energy loss. So that's the after impact. That's in the swing of it all. So then to backtrack for the initial speed, we need to realize that momentum initial is going to equal momentum final. So that means mass of the bullet times the velocity of the bullet is going to equal the mass of the bullet plus the mass of the big block times the velocity after. Well, the velocity after we just said was 2gh. So that means the velocity before is going to be the mass of the bullet plus the mass of the big block over the mass of the bullet times the square root of 2gh. So I know I've got 2 kilograms, I've got 500 grams, so 0.5 kilograms. I'm going to divide that by 0.5 kilograms. So this is going to be 5. And then I've got 2gh here. So 2 times gravity, which is 9.8, times my height, which is 0.03 meters. And then I'm going to take the square root of that answer. I'm going to multiply that by 5. So that is going to tell me the velocity of the bullet before the collision is 3.83 meters per second. So this is an inelastic collision the collision is going to be losing energy. How do I know? Well, we have some deformation there. So that's kind of our number one hallmark. How do we know? Because there are things breaking down. So what we're going to do is we're going to look at this. We're going to come back to class next time. I want you guys to try these one more time. But next time we're going to come back to class and we are going to ask questions. We're going to go over this one more time together. And we're going to see what other questions have popped up during this. Okay? I will be posting an exam review. And yes, it will kind of have a little bit of a follow along like this did. So do not be afraid to pause it where you need to.